Hi everyone, I'm Mark Berniak, and at SelfArray we have developed a new manufacturing technique to make direct view LED displays significantly cheaper and faster. So if you're not familiar with direct view LED displays, think about the last time you were in the Crossgates Mall. Walking by that Apple store, you saw that back wall, just one giant, big, beautiful display. That is a direct view LED display. And compared to other display technologies like projection, LCD, or OLED, these direct view LED displays are 30 times brighter, 100 times faster refresh rate, 100 times brighter, and 10 times as efficient. So these make great application spaces for always-on applications, such as indoor advertising, digital cinema, or informatics like in a control room. The issue, though, is that they're just enormously expensive, and that's due to their construction. Right now, inside each pixel is one of these. This is a very, very tiny 1 millimeter on a side packaged LED with a red, green, and blue chip inside. Now, these are packaged this way for convenience. A single robot has to grab and place one of these into the grid one at a time, 8.3 million times for a 4K display. That'll take 20 days with the fastest machine. Now, you could save some money. You could just get rid of the package entirely. Just use those unpackaged LED chips. But you've got a problem. You've just tripled your manufacturing load. Now that manufacturing time is about 2 months to do a 4K display. And this is where SelfArray can help with our massively parallel directed self-assembly technology. So what we're going to do is, if you look at how these displays are put together, they're actually tiled together modules. Each module consisting of an LED pixel panel and back-end electronics. Now, we're not going to concern ourselves with those electronics. That's something the display industry has been doing for years. They're really, really good at it, and we're not going to reinvent the wheel. But we're going to focus instead right here on this pixel panel, which all it is LEDs assembled into a grid array. So with our technology, we can do it massively parallel, and we can assemble these 4K displays in minutes rather than months. So we'll be assembling these displays, selling them directly to the manufacturers in a B2B style sales with a direct inside sales force. They're going to make those with those back-end electronics to produce the final display. So the way we do this is with diamagnetic levitation and vibration. So we have this magnetic stage here, and our LEDs actually have a thin layer of material which causes them to react to the magnetic field. So we pour them onto the stage as it vibrates, and they get shaken and fall into wells in the magnetic field that we can't see. It takes about 5 seconds for this to just completely align and get caught. Once they're all assembled, we can use roll-to-roll technology to pick them up in a very parallel fashion, low touch, high throughput. So this might sound rather complicated, but really it's kind of like balls in a puzzle. If you've ever played this game, just shake the balls around, they fall into the holes. You pick them up all at once if you have something like sticky tape. Now, if we compare that to the competition, what's going on today? We have pick-and-place tools. Those are the machines I told you about. They individually grab the die, put them in place one at a time, rather slow, but you can pre-test every single LED. You're not going to have any dead pixels on your display. Well, it's got its shortcomings, so that's where transfer printing is coming into effect. Transfer printing grabs batches of LEDs directly from the wafers on which they're grown. It's a parallel process, but you can't pre-test the LEDs. So if this one down here is bad, you have to scrap that entire tile. But it's also limited by the size of these wafers. So this is going to be great for your smartphone, smartwatch, but this is not going to be in a large display. So with SelfArray, we get the best of both worlds. We can pre-test every single LED, meaning that we have a very high yield, no dead pixels, but we're also extremely scalable and fast at sub-millimeter pitch. So we can do this faster and cheaper than everyone else. And that's really what our advantage is. If you look at the cost of these displays today, most of the cost is in these packaging of the LED pixels. With our technology, we eliminate that and enable higher throughput, faster assembly speeds, and lower assembly costs, lowering the overall cost of the display about 40 to 50%. And it's that combination of cost savings and speed advantage that really, we believe, will open up the direct view LED display market. And speaking of the markets, the overall market today, we're talking the largest billboards you see in Times Square down to the smallest displays indoors, is about $50 billion today. You just look at those indoor displays like what you see in the Apple Store, it's about 3.2 billion. And I believe that with our SelfArray pixel panel technology, we can carve out about a $500 million market space. But these are just 2016 numbers. This market's expected to more than double in the next 6 years, 16% annually. And those are conservative numbers. We believe that we can act as a catalyst, really bringing this forward, pushing this market to new heights. We have a great team to do it. We've been talking with so everyone I think knows Clint in the room. He's our CEO. Yeah, back there. Well, he's an entrepreneur in residence at RPI. Our CTO is also an RPI professor in the electrical engineering department, Dr. James Liu. He invented this technology. He's an IEEE fellow. And then there's myself, another RPI man, just graduated in material science in the characterization, growth, and fabrication of LEDs, and now I'm on product development. So we're located just down the road in the Quackenbush building on the 3rd floor above the center of gravity. We're an NSF SBIR Phase 1 grantee. We've completed the NSF I-Core site program, as well as Phase 1 of the Nexus New York Clean Energy Seed Accelerator. In fact, we just were awarded Phase 2. Found out about that yesterday. So, thank you, yeah. So between those two programs, we've had the opportunity to go out there, outside the lab, talk to customers, really learn what their problems are, apply our theory, and really validate our value proposition. And we're talking top display makers, market researchers, chip suppliers, and all of them have agreed that there's a paradigm shift coming in the display industry, away from those packaged devices toward this unpackaged approach. And everyone has also admitted that no one has a good way to do this yet. Everyone is out there searching for the next big idea, either from a startup or a university, and at SelfArray, we're answering that call. And that's where we could use your help. If you know anyone in the display industry or the display business, especially the direct-to-view LED display business, I would love to talk to you afterwards, or you can shoot me an email, please. Also, we are currently raising private capital, and if you know anything about PCB design or flip chip bonding, that is the next critical step we have in our prototype development. So if you have any questions, please visit our website, shoot me an email, or find me afterwards, but I'll happily take your questions now. Thank you. All right.
You have a prototype already?
So we have a prototype of the assembly process, and we just received some LEDs today, and we should have a full working mini display in about 6 weeks. Any other questions?
Where are you manufacturing?
So right now, we're manufacturing right in our office above the center of gravity. Yes, please.
What stage is your IP at?
So our IP right now, we have the main patent is currently under review from the U.S. Department of Patent Office, and it is a file wrapper. We just got it a few days ago. Everything went through except for one claim, and we're filing that also in 10 different countries. And then besides that, which we have exclusive licensing through RPI, we have our own patent pending technology around some of the other things like the transfer, the process, the stage design, and things like that. Yes, back there.
Is there any difference between the direct view displays you mentioned and the 4K displays that I haven't?
Yeah, so that's a great question. So the difference between direct view LED displays and the 4K LED TVs, that's a great question. It's a common misconception. LED TVs that you see at Best Buy, those are actually just LCD TVs with LEDs as the backlights. So the difference is that our pixels aren't LCD, they're not liquid crystal. Each one of them is actually a red, a green, and a blue LED. So the 4K is just the resolution. We're still going to have 8.3 million pixels, but we're going to have 24 million LEDs.